Today's notes are on graphs of sine and cosine, and you saw a little bit of this in Algebra 2, but hopefully we'll get a better understanding of these graphs now in Precalculus. So first example says graph the function y equals the sine of x. Well, one thing we can do to graph any function is to make a table of x, y values. Okay, and x can be any value. Now, we could plug in something in degrees, but usually we use radians. So I'm going to put in different radian values like 0, like pi over 6, like pi over 4. So basically I'm using some of the common ones, pi over 3. And in fact, you might want to have your unit circle handy, pi over 2, because all of these values can be found on that unit circle. And in fact, I'm going to get at least another one here. Let's say pi, let's say 2 pi. Okay? Okay, so we're saying y equals the sine of x. So sine of 0. Now remember on your unit circle, sine is the y coordinate, so you can take a look on the unit circle. Sine of 0 is just 0. Sine of pi over 6 is 1/2. Sine of pi over 4 is square root of 2 over 2, which is about equal to 0.7. Now I'm changing it to a decimal simply because it'll be easier to graph that way. Sine of pi over 3 is square root of 3 over 2, which is about equal to 0.86. Sine of pi over 2 is 1. Sine of pi is 0, and sine of 2 pi is also 0. Okay, so let's plot these points. Now you will notice that your y values are between 0 and 1. You can have some negative y values, but you won't have any values greater than 1 or less than negative 1. Thinking about how the unit circle works, there are no values on there greater than 1 or less than negative 1. Okay, let's see here. I'm going to put pi out here on my graph. I'll put 2 pi on that x-axis over here. We've got 0, so 0, 0 is a point on our graph. Pi over 6, so a sixth of the way to pi, we go up to 1/2. A quarter of the way to pi, we go up to 0.7. A third of the way to pi, we go up to 0.86. And halfway to pi, we go up to 1. Now, if we kept getting values, we'd get the similar kind of values coming back downward here, and we'd see a nice smooth curve going back down here to pi. And around your unit circle, you'll see some negative values do the same exact thing. You'll hit a negative extreme right here, and it'll come down, hit that point, curve back upward. Whoops, I missed that. I'll have to make that bigger. There we go. And we curve the other direction the same way, follow the same pattern, on and on forever, because as we go around and around this unit circle, we'd see these values repeat over and over and over again. Okay, so there's your sine curve. Now just a few things about that sine curve and about a lot of the different curves that we're going to be exploring. This height right here from the x-axis to the maximum or minimum is what's called the amplitude. This distance here that just gets repeated over and over is what's called the period. So those are two things we're going to be talking about quite a bit over the next couple of weeks. Let's look at another example. So we want to graph y equals the cosine of x. And let's do this without writing down all of our points. Now just like our sine curve, cosine is going to go between 1 and negative 1. Just like our sine curve, we'll see things repeat every 2 pi units because around the unit circle things will repeat. Now cosine is your x coordinate on the unit circle, so the cosine at 0 radians is 1. The cosine at pi over 2 is 0. At pi radians, cosine is negative 1. At 3 pi over 2, it's back to 0, and at 2 pi, it's back to 1. So there's your period. It's going to start repeating. Now, don't just connect these with a v. This is going to be a smooth curve like we saw before. Ooh, I hope I can make a nice smooth curve here. And there we go. And again, it goes on and on forever in both directions. So I'm going to do something like that to show it goes on and on forever. Now you'll notice the sine curve and the cosine curve have the same general shape. Sine curve just starts at the origin. Cosine curve starts up 1 unit, but same general shape on and on forever. Okay, keep that in mind. That'll help us in our graphs of sine and cosine curves. Now, a few things that you'll notice about all of these graphs. Okay, we can talk about these just in general, and we can say A, that number in front, remember that's a vertical stretch when we talked about transformations. The absolute value of A is equal to the amplitude. So that number there gives the vertical stretch. Now this value in here multiplied by x determines your period. So period of a sine or cosine curve is 2 pi, but if we have some value there, we can take 2 pi divided by that value, and that'll tell us our period. Okay, so let's look at an example where we might have a different amplitude and or period. So first one, we've got y equals 3 times the sine of x. Now we know, I'm going to sketch this in, I'm going to use this dashed one here. We know that a sine curve will go between 1 and -1, and will look something like this. On and on forever in both directions. Okay, we know it's going to repeat every 2 pi units. And it's going to go through here every pi units. Okay, now there's your curve y equals the sine of x. If we change this so that it's y equals 3 times the sine of x, all that's going to do is it's going to make it so instead of going up to 1 down to -1, it's going to go up to 3 down to -3. So my curve's going to look something like this. It's going to go up here up to 3. It's going to go through the x-axis at the same point, down to -3, up to 3, down to -3, on and on forever, just like our sine curve did before. Period doesn't change. I better label this. This is 2 pi. This is pi. There's still a maximum value at pi over 2. There's still a minimum value at 3 pi over 2. Let's look at this next one. Y equals -5 times the sine of x. Well, that means our amplitude now is going to go up 5 units and down 5 units. In fact, the negative means instead of starting going upward, it's going to start going downward. Go to this minimum value, go through the x-axis at pi, go to a maximum value at 3 pi over 2, and go through the x-axis at 2 pi. So still a nice smooth curve. However, it's going up quite a bit and down quite a bit to 5 and -5. And again, this thing is going on and on forever in both directions, just like any sine or cosine curve. So by putting a number in front of your sine or cosine of x, that's going to change the vertical stretch. Now let's look at an example of putting a number inside the function. And we've actually got two things going on. There is a 3 outside. That means your amplitude is going to be 3. So this curve is going to go up to 3, down to -3. What is this 4 in here going to do? Well, your regular period of a sine curve is 2 pi. If you take 2 pi divided by this value here, you'll have your new period. So the period is now going to be equal to pi over 2. Which means, okay, I'm going to put pi out here on the x-axis, 2 pi out here on the x-axis. We'll put pi over 2 here. We'll put 3 pi over 2. This entire curve, instead of, let's see here, instead of going up and down and repeating every 2 pi units, ooh, that's not right at all. Let's get rid of that. Instead of going up and down repeating every 2 pi units, something like this, it's going to repeat every pi over 2 units. So it's going to go up, down, and repeat right here. Up, down, repeat right here. Okay, so let's get rid of some of this stuff and let's draw that in there. So it's going to start at that origin again. Up, down, repeat right here. Up, down, repeat every pi over 2 units it's going to repeat. So it's going to go up through the axis. So it's going to have a maximum here, down, and repeat right here. So let's see if I can get this drawn in here. Up, down, repeat at pi over 2. Up, down again, repeat at pi. Up, down again, repeat at 3 pi over 2, and up, down again, repeat at 2 pi. And it's going to continue on and on forever doing that. So really what this 4 does in here, it means there's going to be 4 complete periods of this graph where there would normally just be 1. So any value in here, that tells you how often your graph is going to repeat within 2 pi units. In this case, there are 4 complete periods within what would normally be 1 period of this curve. Okay, let's look at another example of that, but let's use a cosine curve. So we need to graph y equals 2 times the cosine of x over 3. Well, first of all, that 2 in front tells us that my amplitude is 2, so it's going to go between 2 and negative 2. Now my usual cosine curve will repeat every 2 pi units. So here's pi, here's 2 pi. So our usual cosine curve starts up here, comes down and through, up, and at 2 pi it starts to repeat again. There's my usual cosine curve. This curve is going to have a different period though. So my new period is going to be 2 pi divided by, well, what do we divide by? Well, this instead of thinking of this as x over 3, think of this as 1/3 x. So we can say 2 pi divided by 1/3, which if you multiply top and bottom by 3, that gives you 6 pi. So that means this graph is going to repeat every 6 pi units. Now to deal with that, I'm just going to change my scale. So I'm going to make my scale so this is 6 pi right here, which means this is 3 pi. Okay, so this curve is going to start up 2 units because the amplitude is 2. At 6 pi, it's going to repeat. Halfway between there, it's going to hit its minimum value. Between those, it's going to go through this axis. So this is actually going to be at 3 pi over 2. And this one's going to be at, what would that be? Let's see here. 9 pi over 2. Okay, so let me sketch that curve. Ooh, not the smoothest curve you'll ever see, but you get the idea, and it goes on and on forever, following that same pattern. All right, so basically, number in front gives the amplitude, how high or low your curve will go. The number multiplied by x tells you something about your period. If that number multiplied by x is less than 1, like in this case, the graph will be stretched out more. If it's something greater than 1, you'll have many more of those going up and down. Okay, let's look at some other things that could be possibly going on. So your general sine curve looks like this. Starts at the origin, goes up, down, repeats forever. General cosine curve starts up 1 unit, goes up, down, repeats forever. Now, just like any other function, we can have different transformations do different things. Now, we already know about this value a, what a does. So I'm going to write that down. The absolute value of a is the amplitude. We already know multiplying x by something, this b, will change the period. So I'm going to write down b leads to 2 pi over b, which equals the period. Now what c will do, think about any function. If you add or subtracting in parentheses here, what c will do, c will lead to a horizontal shift. Now we have to be careful here because b could affect the shift as well. So I'll talk about how to deal with that. But d, adding a number outside here, this is going to be equal to, this is exactly the vertical shift. So this could shift your graph up or down. All right, so let's talk about how to deal with c here. So what we do is we know that at 0 and at 2 pi, we kind of have the borders of one period of our graph. It's going to repeat every 2 pi units. Okay, so what we do is we take what's in parentheses, we say let's take bx minus c and set it equal to 0. And this will give me what I like to call our starting point. And I'll put that in quotes because this graph doesn't really have a starting point because it goes on and on forever in both directions. And if we set bx minus c equal to 2 pi and solve for x, that'll tell us our, and I'll put it in quotes again, our ending point. So what that might do is say, if we solve this for x and find x equals pi, that means start your graph at pi units, go up, down, and end your graph at whatever x is in this equation. Kind of confusing. Let's look at a few examples that use that. So sixth example today, it says, let's graph y equals the sine of x plus pi. So notice I didn't do anything with our vertical shift or our amplitude. So we know our general sine curve starts at the origin, goes up, down, repeats every 2 pi units. Okay, and it keeps doing that on and on forever in both directions. Starts at 0, ends at 2 pi. All right, let's talk about what this graph here is going to do. And I'm going to get rid of that stuff on there. And what we do is we say, okay, we need to find our new starting point. We know this is going to give us a horizontal shift. So I'm going to set x plus pi equal to 0, our regular starting point, and x plus pi equal to 2 pi, our regular ending point. If we solve this first equation for x, we get x equals negative pi. And if we solve this one for x, we get x equals pi. Here's what that means. Instead of starting at the origin and going up, down, repeat, we're going to start at pi and go up, down, repeat. Instead of ending at 2 pi, we're going to end at, oops, excuse me, that's negative pi. We're going to end at pi. So let me graph this curve. So here's like your new origin. It's going to go up, down, up again. It's going to repeat right here. So let's get some halfway points in here. We know this will go up 1 unit. We know this is going to go down 1 unit as well. So our curve is going to look something like this. And there's the graph of y equals the sine of x plus pi. So notice it actually just took that graph, that original graph, which would be here, starting at the origin, up, down, repeat every 2 pi units, and moving it over. So adding or subtracting something in here could shift your graph left or right. All right, let's look at another example of that. So now we have y equals the cosine of x plus 3. Actually, something a little bit different going on because we're not adding 3. This is what's not happening. We're not adding 3 in parentheses like this. Instead, we're adding 3 to the end of our function. So here's what's going on here. It's saying graph this, then add 3 to every value that you get. Okay, adding 3 at the end of a function is going to give us a vertical shift. Okay, so let's just think about this. If we had to just graph y equals the cosine of x, y equals the cosine of x would start up 1 unit. It would repeat every 2 pi units, so at 2 pi it would be up here once again. Halfway through at pi units it would be down here, and it would hit these in between points as well. So it looks something kind of like so. And again, it repeats on and on forever in both directions. What this is saying is that we are going to shift this graph 3 units up. So 1, 2, 3 units up. We're going to have the same exact graph 3 units up from here. So I'm going to get a new axis up here. And this graph is going to go up and down around that axis. So cosine curve starts up 1 unit. So this is actually going to start up 4 units. At 2 pi, it's going to start repeating. At pi, it'll be at its minimum value. And then we've got these halfway points in here as well. So it's the same exact curve, just shifted up 3 units. And I suppose I could have just taken this original curve, picked it up, put it up there, but we'll leave it down here. So y equals the cosine of x plus 3. We graph the same way, except everything is shifted up 3 units. Notice it didn't stretch it out anymore vertically. It didn't change anything horizontally. It's just picking up that curve and moving it everything up 3 units. Okay, let's look at another example here. Got a couple more examples to talk about. So notice in this example, a few different things are going on. Okay, so first of all, adding pi over 2 in here is going to give us a horizontal shift. Subtracting 1 out here is going to give us a vertical shift. So we've got a couple different things going on. So I want to start by just graphing what our regular sine curve looks like. Y equals the sine of x. Starts here at the origin. At pi and at 2 pi, it's going to go through this axis. At 2 pi, it's going to start repeating. At 1 and at negative 1, we'll have our maximum and minimum points. So it's going to look something like this. It's going to go up here, down here, and so on. And again, it's going to repeat on and on forever. Okay, now we've got a few different transformations happening. First of all, this negative 1 is going to give us a new axis, a new x-axis down 1 unit. So our graph is going to go up and down around this new axis. Second of all, this plus pi over 2 is going to change our starting and ending points. So I'm going to put x plus pi over 2 equal to 0 to find our new starting point, and x plus pi over 2 equal to 2 pi to find our new ending point. If I subtract pi over 2 from both sides, I get x equals negative pi over 2. And subtracting pi over 2 from both sides, I get x equals 3 pi over 2. So that means our new starting point is going to be here at negative pi over 2. Our new ending point is going to be here at 3 pi over 2. Now remember, we've got a new x-axis, so we're going to start down here on this new axis. It's going to repeat right here at 3 pi over 2. Halfway between there to go through the axis again. Between those we'll have a maximum value and a minimum value. So our new curve is going to look something like this. Going to go up, down through here. Here it's going to start to repeat, and actually we could keep going on, and this will go on and on the other direction as well. So really, the minus 1 allowed us to take our original graph, shift it down 1. The pi over 2 in parentheses took your original graph and moved it to the left, pi over 2. So here's your original sine curve. Our new one is in black. All right, let me run through one final example. This is it, I promise. We've got all kinds of transformations going on here. We are graphing y equals 3 times the sine of 2x plus pi plus 5. And I'm just going to start by getting our regular sine curve. Starts here at 0. It repeats every 2 pi units. We know it's going to go up 1. We know down 1. And I'm going to get some points on here. So our curve's going to look something like this. Okay, so let's talk about all these transformations. So first of all, plus 5 means that up 5 units is going to be our new x-axis. So I'm going to put a dotted line at that new axis, up 5 units. So there's your new x-axis. 3 means that your graph is going to go up 3 units and down 3 units from there. So 1, 2, 3. So it's going to go from this value 2 up to this value. Let's extend that, which is 3, 4, 5, 6, 7, which is 8. Your new period is going to be 2 pi over b, which is 2. So your new period is going to be pi. It's going to repeat every pi units. We're going to have a new starting point. And let's set 2x plus pi equal to 0. And if we solve that for x, we get 2x equals negative pi. X equals negative pi over 2. There's your new starting point. And your new ending point, we'll set 2x plus pi equal to 2 pi. If we subtract pi from both sides, we get 2x equals pi. Divided by 2 gives us x equals pi over 2. All right, so instead of starting right here at the origin where we normally would, we're going to start pi over 2 units to the left. Instead of ending over here at 2 pi, we're going to end pi over 2 units to the right. This graph is going to go up 3 units, down 3 units. So we're going to have a curve that looks something like this. Going to go up here and down, up here and down, and keep on repeating on and on forever. All right, that's a lot. If you can do something like that, you can do anything I can possibly throw at you. So let's practice some of those. So on page 304, there's a homework assignment. Complete this assignment before watching the next video, please. Let's see what you can do on the assignment on page 304.